Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm your host today. My name is Whitney Lee, and I'm a CNCF ambassador and a developer advocate at VMware Tanzu. Every week on Cloud Native Live, we bring a new set of presenters to showcase how to work with cloud native technologies. We will build things, we will break things, and we will answer your questions. This week, we have Safi Janis here with us to deliver a presentation called IaC Migration Using AI, from CloudFormation to Terraform in Seconds. Now, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. What does that mean? It basically means just be the nice, the kind humans that you are. So please don't add anything to chat that would be in violation of the Code of Conduct, anything that would be disrespectful at all to your fellow participants or to the presenters. Be nice to me too, please, and Sefi. So anyway, friends who are joining us live, if you have questions, please post them to chat. What we're going to do is after the presentation's over, that's when we're going to answer all of your questions. We're going to have a discussion time at the end. And so with that, I'll hand it over to Safi Janis to kick off today's presentation. Safi, tell us about yourself.
Yeah, so first, thank you very much for having me. I'm Safi Yanis, and I'm the CTO and co-founder of Firefly. And today I'm going to talk about leveraging AI for migrating your infrastructure as code from one IaC tool to another. Before that, I'd like to explain about my company, Firefly. It's a cloud asset management solution that scans the entire cloud footprint. I mean, all the hyperscalers, Kubernetes clusters, SaaS applications, etc. In Firefly, we also analyze the infrastructure as code from Terraform to Helm charts, and we detect a discrepancy between the cloud and the IaC. We built a technology that can generate Terraform code with models for something that was created manually before in the cloud. We detect drifts and unexpected changes continuously. And we also adapted layers of policies using Open Policy Agent. I will talk about it in this session as well. And we can govern the cloud for FinOps, SecOps, and reliability. And again, thank you very much for having me.
This is all very exciting. I'm looking forward to digging into the code. So I'm going to go ahead and share your screen now so you can get started.
Okay, super. So in this talk, I will discuss an IaC. IaC is an open source tool that we recently launched that helps migrate infrastructure as code or helps generate infrastructure as code using AI. So we adapted OpenAI, and we utilize OpenAI in order to generate Terraform code, CloudFormation, etc. And I will show you what you can do using IaC. Here under our documentation, and by the way, we have 2.7K stars. You are more than welcome to start this Git repository. But we have some examples for utilizing this great tool. The first one is to generate new infrastructure as code. If now you want to create a new Lambda function with the models and variables under VPC, etc., you can use this open source tool and it would generate the Terraform code for you or CloudFormation. You can also generate Docker file or a Kubernetes manifest. In this session, I will also show you how I generated CI/CD pipeline using IaC, and this is really powerful because you know how difficult it is to write YML files. This tool can also help generating policies code, OPA, and even query builder. For instance, if you have MongoDB or Elasticsearch and you need to build a sophisticated query using this tool, you can do that. And I showed you the tool, I explained very briefly, but let's dive into the code. And in this specific session, I will show you how I can migrate one IaC to another. For example, I built a CloudFormation stack. I will show you that a CloudFormation stack that builds an application in a dedicated VPC in some configuration. I'll elaborate on that. I will launch this CloudFormation stack, and then I will show you how we can utilize this tool to migrate the CloudFormation to Terraform. But that's just an example. Using this great tool, you can migrate every IaC infrastructure as code tool to whatever you want. You can migrate Terraform to Crossplane or CloudFormation to Poolway. And I'm going to the first step here, and let's dive into the code. Cool. So the first thing that I'm going to do right now is to launch a CloudFormation stack. And hold on, I will connect to my AWS account. Super. Okay, so I'm launching right now a CloudFormation stack that will create 25 resources, and it will build a new application. It takes around 2 or 3 minutes, but I'd like to dive into the CloudFormation just to explain what it is. And of course, that's just an example. You can use any microservice that you have, a backend, a front end, or other infrastructure in the cloud. As you can see here, this specific CloudFormation stack, I deployed a dedicated VPC because I built my application and isolated it into a virtual private cloud. I built 4 subnets, 2 public and 2 private subnets. Okay. I also created an internet gateway because somehow we need to transfer the networking outside to the entire world.
Will you make it a little bigger, please?
Yes. Sure.
Thank you.
Okay. Is it good enough right now?
Yes, thank you.
Okay. So as I mentioned, we built here a VPC, 4 subnets, 2 public and 2 private internet gateway, because we need to transfer the data outside of our VPC. We also configured the Route 50 route table, public and private. Public will transfer the data through the internet gateway. You can see that we built EC2 machine. The user data will launch the application. Also a load balancer because we want to build an high available solution. Security groups for the load balancer and the EC2, network ACL, and I think that you got the idea here. And let's see if the resources in the CloudFormation were created. Maybe it will take one more moment, but let's, okay. So, and it takes one more moment, and I will show you an example for IaC in that time. So using IaC, we can build, for example, Terraform code for a Lambda, function under a VPC. I just closed the YML file. I don't know why it stuck my computer. For a Lambda function under VPC. Now, around 20 seconds, and you will get the Terraform code. But IaC is a great tool because it's like a chat. You can continuously talk with the IaC. And if now I would like to add security layers on this codified resource, we can do that. We can also generate the code and save a README empty file. And that's super powerful. You can see here, and I will show you the result. I hope that it's not small enough. You can see that it creates the VPC, the security group, and the Lambda function here. Hold on. Okay, the Lambda function with the VPC configuration, exactly as we wanted. And I'll show you more examples for IaC, but I'm going back to the CloudFormation stack. I want to see that the resources were deployed, and yes, right now we have a cool. That's a web application that we launched with 25 resources, and that's CloudFormation. And we want to migrate this to Terraform, and I'm going to step 2 of my talk. So what I've done is I went to the CloudFormation template, And I copied the VPC and the subnet just for explanation and demonstration. And I created an input file called networking.txt because I would like to utilize IaC, but I need to read the data. If I'm migrating CloudFormation to Terraform, I need to read the CloudFormation and to run a prompt. And I'm going to show you right now that I will run the following commands. And I will show you this here.
Can you make that bigger, your terminal bigger?
Yes, that's exactly what I'm trying to do. Let's
okay.
try here.
Excellent.
I will write here and I'll copy the. I can't do it bigger. Okay, resize. Never mind. Okay, so what I'm going to run right now, and I'll try to do my best, is to read the networking.txt file that I showed you. That's part of the CloudFormation stack, and I pass the data here into a variable called input. And then I'm running the command IaC get Terraform code with variables for following CloudFormation. That is CloudFormation stack, and I'm using the output variable to save the Terraform code into the directory output and file called network.ntf. Also added the quiet flag. So here I will run this. Okay. And let's run the IaC get Terraform code. Takes 15-20 minutes, and you will see that it generates the Terraform code for the VPC and the 4 subnet that I picked. And of course, I can do it for everything, but I just wanted to show you how it looks like. And let's save it. Okay, now it's saved here in the folder called outputs in the networking file. Okay, you can see that we have a VPC exactly as it was migrated from CloudFormation, subnets, etc. And again, the open source tool called IaC, I just walk you through that, IaC.dev, that's the open source tool that you can run and install using Bro or using a Docker file. Cool. So we have Terraform code, and I also added a provider TF for being able to run this code. And let's try to run Terraform init. In Terraform, we need to run the Terraform init, plan, and then apply in order to deploy the resources. But my problem here is that I'm going to apply something that is already applied because it exists in the cloud. I've already created the resources using the CloudFormation. Now I declare the Terraform code, but I will not be able to apply it again because the resource is already exists. And if I will show you the Terraform plan, we will see 5 resources are going to be added. Okay, you can see 5 to add, 0 to change, 0 to destroy, but the resources already exist. So we need to import them into our Terraform state. Otherwise, I won't be able to recreate. And this is a bit more sophisticated. I just would like to mention that in Terraform 1.5, they added a new capability that you can use an import block, looks like that. And you just need to mention the specific resource from the cloud account. But I will go to the AWS, to the Terraform documentation. I'm going to the AWS VPC documentation. And here you will see the Terraform import command. It looks like that. Terraform import, the resource type, the name in the code, and the ID. So I'm going back to the code and run Terraform import AWS VPC. Then let's see, the name is my VPC, and we want to import this one. Okay, import successful. And if now I will run the Terraform plan, we'll see only 4 resources that are going to be created. But what happens if right now I have 100 or 1,000 resources? It's tough, and that's why in Firefly we automate this solution. And as I mentioned before, Firefly is a cloud asset management solution that can scan the cloud and analyze the IaC, and we can generate the Terraform code and import the resource for you. So you can sign up for free. We have a free tier, and I'm going to show you right now how you can use our platform in order to import resources and to fully automate it using our solution. We also adapted the IaC as part of our product. So here you can see an EC2 instance exactly as this one was created before, but 48 hours left. So I will read again. Okay, we have here an IAM policy. I can codify it. You can see that Firefly generates the Terraform code for you. We also detect dependencies. Sometimes you have resources with the dependencies like Lambda function under VPC and subnet, etc. We detect all of them. We can create models for everything that you want, and you see that everything is fully mutable. Instead of put value here, we can deploy it in staging, prod, etc. But what I wanted to show you is that you can click on the import command button, and Firefly will generate the import CMD. And using that, we automate this process, and we can create pull requests back to your Git. But I would like to continue with this session. And before continuing so far, does anyone have questions?
We do have a question right now from Chris.
Okay.
I have CloudFormation templates. I'm trying to move to Terraform. I see 2 options. 1, import into Terraform and then do show plan to see the plan and get the Terraform code. Or 2, use IaC. Which is the better option?
I would say IaC because that's fully AI and can help you leverage it. But the truth is that is not that there is no one answer for architecture for a question like that. You should do whatever works for you. But IaC, I can tell you that I tried to automate this, and it took me like 5 minutes, and I succeeded to migrate my CloudFormation to Terraform.
So in the end, it's the same result, regardless of which way you go. It's just a matter of the IaC will be more simple. Or actually, maybe Chris is asking a similar question as me, which will generate higher quality results.
If you use the Terraform, okay. It depends. It really depends. I can tell you that IaC utilize a non-deterministic approach. So you can generate everything that you want. If right now you would like to migrate a Lambda function, but you want to add more configuration, policies, roles, etc. So without IaC, you need to write those resources manually. Or what happens if you want to codify models? So I suggest to use non-deterministic solutions, or as I mentioned before, in Firefly, we do a great job for help you codifying resources with existing models.
Thanks for that. And thanks for asking questions, Chris. We appreciate you.
Okay. Super. Should we, let's continue and then we'll stop for more questions. Thank you. So I just showed you right now an example for migrating some of my resources into Terraform. But I have done this before and built an whole solution using the same technique. And you can see that right now I have Terraform code with all the resources, the provider, output, etc. So let's run the Terraform apply command. 1 second. I took the Terraform code and I decided to deploy it in an isolated account. So I deployed the CloudFormation account A, then I migrated to Terraform and deployed the Terraform in account B. And you can see that it totally works. I have here a DNS, and let's run it, and it will be the same architecture, the same thing as you see in account A. But right now, this one is deployed using Terraform. And why I'm telling you this, because that's really useful for you to migrate the IaC. And not just that, also to generate Terraform code, etc. And one moment. Cool. I would like to show you one more thing that you can do using IaC. And I'm going back to the Git repository. You remember that before I told you about generating CI/CD pipelines. You understand that running the Terraform code from your local machine is not a good practice. And the best practice is to use CI/CD to store the state files in a remote backend, etc. And that's exactly what I'm going to demonstrate right now. I built here a readme.md using IaC. You can see the command. And I will use IaC to generate a GitHub action for deploying Terraform. And then I'd like to add a security check for the existing CI/CD pipeline. So I'm running here this, the IaC get GitHub action for deploying Terraform.
While we're waiting, we have a quick question, and that is, will IaC work for Azure?
What do you mean?
I think we're showing an AWS example here. Does it work for all the cloud providers?
Yes, it's a multi-provider because it's not deterministic. You can also generate Terraform code for GitHub or Datadog or other providers.
Excellent.
And Kubernetes as well. Yeah, good. So you can see here that the IaC generated the pipeline, and right now I know that it's a bit small, but you will see the Terraform import, Terraform plan, Terraform apply, but we don't have any security check. And that's why I will ask the IaC to continue the chat. And the new message is add IaC security scanning stack. And then I will save it into a dedicated YML file. I will use this file and I will show you in a real Git repository the result. Okay. So you see that we have also one more step with TFSec. TFSec is a great open source tool that was created by Aqua Security, additional layer of security. And let's save it into, 1 second, let's save it into the folder. Let's call it temp2.yml, just for example. Super. Cool. So right now you can see that IaC generated using generative AI, CI/CD pipeline, full CI/CD pipeline that set the Terraform code, Terraform init, also the security scanning. And I did the same before, and I already configured the Git repository and want to show you the results for that. Okay, I'm going to the GitHub action, and you can see right now that this one, that's the CI/CD. I ran the Terraform init run successfully. The
Will you
Terraform plan,
make it
yeah,
bigger, please? Thank you.
yes, sure. So you can see that we set up the CI/CD pipeline. Everything is, you saw 5 seconds using AI. I got the YML file, I put it in my Git repository, and from now on, I have a full CI/CD pipeline running. The Terraform init works, the Terraform plan also works, and that's the security checker. And let's walk through the results. It failed. Ensure VPC, okay, that's a nice control that is talking about assigning public IP in a VPC. It's something that must be configured, or load balancer in across the availability zone, or many other controls for security, like users without MFA, public accessible assets, etc. That's focused. This is focused on security. And now I'm going to introduce you to a different open source tool that we have launched in Firefly a year ago, called Valid IaC. Because you saw that you can utilize security checkers to streamline, to leverage your CI/CD pipeline. But Valid IaC is an open source tool that is one place that run all of the analyzers, the TFSec, InfraCost, InfraMap, TFLint, etc. And using that, it will help you not just with security, also with cost, or with linter, or with map. And here we have an example for some resource. Resource says VPC with subnet, etc. We will run the security. Behind, we run the TFSec. TFSec, by the way, today is Trivi. Aqua, they do a great job there. And you will see that we have 2 potential problems and 1 resource passed. But if I'm going to the cost, you can see that we have $505 over total. That's the total price of those resources, probably because of this instance. Okay, M6A. We can also generate the map or the linter. So that's Valid IaC. You can use it as well, and you can put Valid IaC as part of your CI/CD pipeline. And I open for any questions from your side.
We have a question about enterprise code scanners. How would you change? How would you change to other enterprise code scanners rather than Aqua?
I can recommend, I know some code scanners, TFSec or Trivi that was created by Aqua is a good one, but Chekhov that was created by Bridge Crew is also a great solution. It's Palo Alto Network acquired this specifically. They are more the same. Kix that was acquired by, that was built by Checkmarks is also a great open source tool. Each of them has pros and cons. For example, Kix, I'm not an advocate of none of them, but all of them are great. Kix is based on OPA, and using that you can leverage your own policies, or you can build policies using IaC and put in Kix your own policies and govern your infrastructure as code. TFSec or Trivi, they're great. They have some controls to help you with infrastructure, and all of them are great.
I have a question. Are there like best practices around using AI as part of IaC?
Yes.
Yeah.
Sure. Thank you for asking that. It's a really important question. The first thing is regarding secrets, anthropies, API keys, etc. You should never pass your data, your sensitive information to ChatGPT or other AI systems. It's dangerous. And one of the ways to avoid this is to use Git leaks. Git leaks is a great open source tool that can detect secrets, and you should understand what you pass into AI systems. Cool.
That's very helpful. Are there any others, or is it mainly about secret management, you think? Any other best
I,
practices or good practices?
I think that secrets and API keys, that's definitely the top priority, but also customer data, because you should never pass customer data or PII or something that, even if it's not a password, you should be aware of that. And GPT and other solutions are not deterministic, so the result is not always correct. And in GPT, you have something called temperature that you can configure. It's a measure from 0 to 1. And that depends on the creativity of the AI. So if you want the code to be correct without any creativity, you can configure the temperature for 0.
Excellent. I have other questions. As you've been going, I've been typing out my questions. If you see me typing, that's why. Another question. So what I saw in your excellent demo was you had templates already in CloudFormation, and then you migrated those. What if you have resources running, but you don't have templates for them? Can you generate templates?
Oh, that's harder. You mentioned something called ClickOps. What happens
Uh-huh.
if I created something manually in the cloud and I don't
Yeah.
have any IaC, what I can do right now? And
Yeah.
that's more difficult. And Firefly, by the way, solved this specifically because we scan the entire cloud
Ah,
footprint. So if you have any issue like that, you can sign up for free to Firefly. And
okay.
if I may, I will share for one moment how it looks like.
Oh yeah, you don't need to apologize. I'd never heard the term click ops before. I like that. That's fun.
Sure,
Will you
ClickOps
make
is,
it bigger? Yeah.
yeah, sure.
Thank
ClickOps
you.
is something. Okay, so before that, I think that I need to explain what is ClickOps because that's really important definition. In the real life, some of you, I hope that most of you use infrastructure as code, but you can see that some resources might be created manually in the cloud because of
Mm-hmm.
all resources, etc. That's ClickOps or unmanaged labor. And migrating unmanaged resources into Terraform demands to understand the cloud footprint. And
Mm-hmm.
by the way, today we are the only solution that scan the entire cloud footprint and can generate Terraform code for that. And you can sign up for free and use that. So for instance, this one is an S3 bucket ACL. You can see that this resource was created manually. I can codify it. I can also detect the dependencies. And now I have Terraform code.
Cool. We have a question from chat. This is from Kenneth. Can I create Kubernetes objects? If so, could I also do the inverse and generate YAML manifests from already created Kubernetes cluster objects? So similar question, but with a different technology behind it.
Yeah, so I'll answer this from two different perspectives. If you have some Kubernetes resource and you haven't, okay? And the answer is yes, you can generate, generative AI can do everything for you. So if you have a YAML file or YAML manifest and you want to migrate to Helm charts or to IaC tool, I showed you it's the same. If you have any resource that doesn't exist, but you want IaC to generate the ingress rule for you or to the Kubernetes deployments that will deploy any CRD for Prometheus, for example, you can leverage IaC with the you know what? I will share it. Give
Let's
me
do
1
it.
second.
So I think you answered Kenneth's second question as part of the first question. Does it support the creation of Helm charts? It sounds like it does. Yes.
Yes.
Yeah.
So let's run the following. IaC get Helm charts deployment for ingress rule. Let's start easy. Oh, okay, I will use the second one that I already passed the configuration. So now I'm utilizing IaC, and I will generate the LJobs deployment for Ingress rule. It takes a few seconds, and then we'll see that. We can utilize IaC to migrate one IaC to another, but in the real world, if the resource exists in the cloud or in the Kubernetes, you can use Firefly to generate it. And I will save it into a dedicated file for you.
Is IaC a CLI utility only, or?
No, you can use IaC with Docker or with the Go package.
With Docker or Go package? Cool.
Here. So regarding the Kubernetes question, right now IaC generated Kubernetes and Helm charts with Ingress rule.
Cool. So we've been talking a lot about Terraform. There are other open source projects for cloud provisioning. Offhand, I can think of Crossplane, which you did briefly mention, and Cluster API. Do these work with those too? Are there other cloud provisioning open source projects?
Yeah, definitely. And I'd like to elaborate on Crossplane. That's a really unique and great open source tool. Still immature, but I see that the community adapts and builds great things over there. Crossplane is a Kubernetes-based infrastructure as code tool that helps you to generate one unified resource, a cloud-agnostic IaC. For instance, if now I have S3 bucket, Azure Blob Storage, and GCS, three different resources. In Terraform, we need to generate three different resources. Using a Crossplane, you can build one unified storage and decide in which cloud provider you want to deploy. And this is really interesting solution.
It is really cool. And you can offer your developers a way to self-service provision stuff in a much simpler interface where you have a lot of the defaults set to whatever you want as an operator, and then they can you expose only the knobs of what they need. I'm a Crossplane fan.
Nice.
That's super cool. Yeah. So I think that kind of lends itself to maybe talking about in general, maybe just listing off a lot of different technologies that this is compatible with.
Yeah. So is it a statement or question?
Will you please list some? Please, Sefi, list some technologies that this is compatible with, especially open source ones.
Yeah. Sorry, can you say it again? I didn't get your question.
Oh, so we're talking about just peripherally, we're mentioning a lot of different technologies, like all the different cloud providers or Terraform, Crossplane, policy agents. What other technologies can you use IaC with, or would you want to use this with?
I understand. Okay, thank you for answering thank you for that. So it's not just for infrastructure as code, as I mentioned. We discussed we discussed on Terraform, Pulumi, and all of those solutions. But you can generate a query for the database. Doesn't matter if it's Elasticsearch or MongoDB. I basically don't write regex anymore. Using IaC, I just use this for generating for me.
That's a big sell. That's great.
It is.
Yeah, no more regex. Awesome. So you showed the CloudFormation resources, and then you showed IaC generating Terraform code for just a subset of those resources. And you said that would take 20 minutes or something to generate that. Is that correct? Did I follow that correctly?
To generate the Terraform code? No, it's around 2 minutes, something like that.
Around 2 minutes. Okay, excellent. Yes. So then that makes maybe the rest of my question moot. So if you took all of those CloudFormation resources and did them all at once and made them into Terraform code, how long would that take?
Yeah, so it's not just about how long it takes. In OpenAI, they have some limitation for the payload. And that's why they have a couple of models. And I guess that most of you heard about GPT 3.5 Turbo or GPT 4, but they recently launched a new model that you can leverage it for bigger context. And if you
Okay.
use this, it will be much easier for you um, to migrate the entire cloud formation stack. It takes also around 2 or 3 minutes.
Cool. So we talked about migration. We talked about some generation of stuff. Is there anything else you want to touch on? We talked about policy some a little bit. Is there anything else you want to touch on in terms of capabilities?
Policy, that's a
Yeah.
great discussion. OPA, Open Policy Agent, is
Uh-huh.
also a CNCF solution, a great open source tool for policy
Uh-huh.
enforcement. I know many products in the world that adopted this, some of them for policy enforcement, for authentication, authorization, etc. By the way, in Firefly, we adopted OPA for governing the cloud. Using our
Mhm.
solution, you can run your own rules for detecting EBS GP2 instead of GP3, or public accessible assets, or Kubernetes deployment without CPU or memory limit for all of those purposes. And then going back to IaC, you can generate new policies using IaC.
Oh, nice. Cool. Awesome.
Yeah.
Well, that's all of the questions we have from chat and all of the questions from me personally. Is there anything else you'd like to go over, Sefi?
No, I think that we cover many things, and my takeaway from this discussion is that you should leverage AI today.
Yeah.
I think that everyone should use GitHub Copilot and to use IaC and solutions like that to streamline your day-to-day work. Never save secrets, none for neither for your ChatGPT nor for your code. And you can take a look at Firefly. I believe that we can solve a lot of challenges regarding the pains. And don't forget IaC.dev. That's our open source tool.
Oh, I'll highlight. Here's the open source tool. Check it out, aiac.dev. All right, I'm going to say goodbye. I have thanks everyone for joining today's episode of Cloud Native Live. It was great to have Sefi Janice. Thank you, Sefi, for sharing your time and your expertise with us today. Sefi talked about using AI to migrate infrastructure as code with the open source project IaC. I've loved also the interaction and questions from chat. Thank you all for participating. And here at Cloud Native Live, we bring you the latest cloud native code every Wednesday at noon US Eastern. So thanks for joining us today. Thanks to those who watched the recording, and we'll see you again soon. Thank you so much, y'all. Have a great day.